Microsoft GraphRAG, Local, Global, and DriftSearch. Let's dig in. Quick recap. In Module 2, we did the construction work, turned text into an entity graph, ran Leiden to carve out communities, and pre-wrote a report for each one. That index already exists. So Module 3 isn't about building. It's about reading, given that same graph and those reports, how do we actually ask questions? Here's the elegant idea behind Microsoft GraphRAG, from the Edge et al. Paper from local to global. You build the graph and reports once, paying that cost up front. Then you point different search modes at that one structure. Think one telescope with 3 interchangeable eyepieces, same instrument, 3 very different views. One new word first, TextUnits. GraphRAG slices your documents into configurable chunks, and each chunk is a text unit. They do double duty. At index time, they are what the LLM reads to extract entities, and at query time, they are the raw evidence you pull back. And every entity remembers its text units, which is exactly Module 2 mutual indexing. Let me animate the whole index. Documents come in, get sliced into text units. An LLM reads each one and pulls out entities and relationships that assemble into a graph. Leiden carves that into a hierarchy of communities. Finally, the LLM writes a report per community. Everything after this, local, global, drift, just reads parts of this picture. Why more than one search mode? Because questions come in different shapes. What side effects did drug X report in trial Y? Is a laser wanting a precise fact? What are the major themes across this corpus? Is a floodlight wanting a synthesis? No single strategy is great at both, so GraphRAG gives each its own mode. Let's start with the laser local search for questions that name specific entities. Its strategy is to find the few nodes your question is really about, plant itself there, and read the immediate neighborhood. It's a spotlight on a small relevant corner, deep but narrow. Name a person, drug, or company, and this is usually the right mode. Here's the local search machinery. We embed the question and cosine match it against entity description embeddings to find the top entities, our access points. From those anchors we fan out connected entities, relationships, claims, and candidate text units. We rank everything and pack it using separate token budgets per category, so nothing crowds the others out. Then the LLM answers. That separate budget detail is sneakier than it looks. Dump everything in one pile and the chattiest category, usually raw text units, eats the whole window and starves the relationships. Giving each category its own slice guarantees the LLM sees a balanced meal, some structure, some evidence, some neighborhood. Balance beats raw volume. So local search is fast, precise, and explainable. You can trace which entities produced the answer. But it has one blind spot, it only sees the neighborhood it anchored on. Ask it for the whole dataset's themes, and it'll answer from one tiny corner and miss the forest. It can't see what it never visited, which the next mode fixes. Enter global search, the floodlight, built for broad questions about the whole corpus. The clever move, it doesn't read your raw documents at all. It reads the community reports we pre-wrote at index time, each already summarizing a cluster of entities. So global starts from summaries, not a mountain of text. That's how it surveys a million token corpus without drowning. Let's name what global search really does. Questions like what are the main themes? Aren't retrieval, no single passage holds the answer. Their query-focused summarization, or QFS, summarize the whole collection through the lens of my question. We flagged in Module 1 that classic RAG can't do this. Global search is GraphRAG's answer to that gap. Mechanically, global search is a MapReduce. In the MAP step, every selected community report independently answers the question and self-assigns a helpfulness score from 0 to 100. Then we filter, dropping the low scorers that admitted they had nothing. Finally, reduce fuses the survivors into one answer. Many small summaries in, one synthesis out. Don't skip that helpfulness score, it keeps global search honest. Without it, every community contributes equally, and a cluster about sports schedules dilutes a question about economic policy. By having each community rate its own relevance and dropping the duds, the reduce step only fuses signal. It's cheap LLM native relevance filtering baked into the map phase. Now a knob you controls. Recall from Module 2 that Leiden produced a hierarchy, broad themes at level 0, finer neighborhoods deeper down. Global search lets you choose which level to summarize at. The root gives a few big reports, cheap but coarse. Go deeper for many richer reports, more nuance, more tokens. The level dial is your cost versus detail trade-off. Does the floodlight beat the alternatives? The paper tested it on roughly million token corpora, podcasts and news, on broad sense-making questions. Against naive RAG, GraphRAG's global search won substantially on comprehensiveness, covering more of what mattered and diversity, surfacing a wider range of points. And it kept scaling as questions got broader. Let's lock in the contrast. Local anchors on entities, reads the raw neighborhood, goes deep and narrow and is cheap. Global reads community summaries, sweeps the corpus via MapReduce, goes broad and shallow on any single fact and costs more. Two clean modes for two clean question shapes. But you can feel this coming, real questions are rarely so clean. Here's the awkward middle. Take how did supply chain disruptions affect this specific company's quarter? That's broad, it needs the big picture of supply chains. But it's also grounded, it needs one company's specific numbers. Local misses the macro context, global blurs the specific fact. We need something that starts global and drills down to local. That's Drift. Drift stands for dynamic reasoning and inference with flexible traversal. Built by uncharted software on top of GraphRAG, it refuses to pick a lane. Instead of choosing global or local, it starts with a global orientation from community reports, then iteratively drills into local detail, following its own curiosity. It's less a single query, more a little guided investigation. Drift runs in 3 phases. The primer does a light global pass to draft a rough answer plus follow-up questions. The follow-up loop runs each follow-up as a local search, learning and spawning new follow-ups, a couple of rounds. Consolidation ranks everything and fuses it into one answer holding both the big picture and the fine detail. Let's slow down on each phase. The primer is a stripped-down global search. It compares your query to the top K community reports and produces 2 things, a broad draft answer and several follow-up questions. Think of it as a research assistant who skims the summaries, gives a rough first take, then says here's what we should look into next. It sets the agenda. Inside the primer hides one of my favorite tricks, HyDE hypothetical document embeddings. A short query makes a thin, weak embedding to search with. So HyDE flips it, asks the LLM to draft a hypothetical answer paragraph first, then embed that rich paragraph instead. A fuller embedding casts a wider, more accurate net over the reports. Answer first, fake it, use it to find the real one. Phase 2 is where Drift earns its name. Each primer follow-up runs as a local search, but a special one that also carries community information so it stays globally aware while digging into local detail. Each run yields an intermediate answer and often fresh follow-ups. Drift loops by default about 2 rounds, chasing the thread deeper. An investigation, not a lookup. After the loop, Drift holds a whole tree of question and answer pairs at different zoom levels. Consolidation cleans this up. It ranks every Q&A by relevance to your original question, then MapReduces them, like globals reduce, into one cohesive answer. The ranking ensures the result carries both the primer's macro context and the follow-up's micro details woven together. What stops Drift from looping forever? A query state and action tree. Drift keeps every QA pair as a node carrying a confidence value. High-confidence nodes are worth expanding, so it branches further there. Low-confidence ones are dead ends, so it stops. Expansion is confidence-driven, not blind. A focused detective, not someone pulling random threads till time runs out. Does all that machinery pay off? They benchmarked Drift against plain local search on over 5,000 AP news articles, using 50 locally targeted questions, local's home turf. Even there, Drift won comprehensiveness 78% of the time and diversity 81%. Adding global orientation up front makes even precise, local flavored answers richer. Let's put all three on one shelf. Local, a named entity, a precise fact, cheapest. Global, a whole corpus theme, a synthesis, moderate cost. Drift, broad but grounded, exploratory, richest answer and priciest. Same index underneath, you're just choosing how aggressively to traverse it. The skill isn't running them, it's knowing which one the question wants. One more decision input cost. These modes form a clean ladder. Local is cheapest, a few targeted lookups. Global costs more, rising as you summarize at deeper levels. Drift is most expensive, a primer plus a multi-round loop, each round firing more LLM calls. So the honest question is never just which answer's best, but is the extra quality worth the spend? Here's a rule of thumb for your pocket. Names a specific entity and wants a fact. Reach for local. Asks about themes across the whole corpus. Reach for global. Broad but grounded, exploratory, or you're not sure. Reach for drift because it gracefully spans the middle. When in doubt, drift is the safe default. It just costs you for the privilege. Concepts locked in. Now we'll actually run these searches in code. But before a single line, we have to meet the tool that makes it possible, Microsoft's GraphRAG library. We'll spend the next few slides getting properly introduced. What it is, how it's set up, what it produces, which objects we'll call, and only then open the editor. No stepping into library code cold. First, what is the GraphRAG library? It's Microsoft Research's official open-source implementation of everything we discussed. A complete data pipeline plus a query engine shipped as a Python package. Install it with a simple pip install GraphRAG. It's CLI first for the common path, with a full Python API underneath. One install gives you both the indexing and the searching sides. Second, setup. You run GraphRAG init at a project root, and it scaffolds a workspace, a settings.yaml file, a folder of editable prompt templates, and an env file for keys. That settings.yaml is mission control, where you declare your models, text unit chunk size, the Leiden parameters, community report settings, and importantly, separate config blocks for local search, global search, and drift search. Third, what indexing produces, the part you'll load in code. You run GraphRAG index, which executes the whole pipeline we animated. When it finishes, it drops Parquet tables on disk, entities, relationships, communities, community reports, and text units, plus a vector store of embeddings. Those Parquet files are the entire searchable index. Every query mode just reads them differently. Fourth, the Python objects you'll instantiate. Each mode is a class paired with a context builder. The builder gathers and packs the right data. The class drives the LLM. Global uses global search with a global community context over reports. Local uses local search with a local search mixed context over entities and text. Drift uses DriftSearch with a DriftSearch context builder. Same pattern 3 times. Fifth, a close look at DriftSearch, since that's what we'll run. You construct it with the chat model, a DriftSearch context builder, and a tokenizer for budget tracking. Its behavior is steered by a DriftSearch config with 3 knobs mapping onto the phases, primer folds for the primer, drift k follow-ups for follow-ups kept per step, and end depth for loop depth. You call it with a wait search.search. Now the lab's complete and end-to-end. We'll wire the full query stack, load the index artifacts, then build and run all 3 engines on the same data, global, local, and the full drift pipeline with its primer, follow-up loop, and consolidation. By the end, you'll have seen every search mode the chapter teaches, running against one index. Let's open the editor. Step 1, load what indexing produced. We read the 5 Parquet tables off disk with pandas, entities, communities, relationships, text units, and community reports. These data frames are the raw on-disk index. Nothing fancy yet. We're just pulling the searchable tables into memory so the query engines have something to read. This is exactly the output of GraphRAG index. Step 2, turn those raw data frames into the typed objects the engines expect. Using GraphRAG's readIndexer helpers, readIndexer entities, and readIndexer reports both take a community level. That's our cost versus detail dial, choosing how deep into the Leiden hierarchy to read. And readIndexer report embeddings loads the report vectors, which is what makes the primer's HyDE search possible. Step 3, our first engine, global search. We hand a global community context builder the community reports and entities. That builder packs reports for the map step. Then global search wraps it with a model and a MapReduce config. When we await search.search, it runs the MapReduce we animated. Every report votes with a partial answer and a score, the duds drop, survivors fuse. Step 4, local search, the entity spotlight on the same data. The local search mixed context builder is the busy one. It takes entities, relationships, text units, reports, and crucially the entity description embeddings, because that's what the query cosine matches against to find access points. Local search wires it to the model. One await later a precise, neighborhood-grounded answer. And now the headliner, drift. Notice we're not stepping into this cold. We've covered the 3 phases, HyDE, the confidence-gated action tree, and on the last few slides the DriftSearch class, its context builder and its config knobs. So the next 2 slides should read like assembling parts you already recognize. Let's build the drift context, set its config, and run it. Step 5, assemble drift context builder and config. The DriftSearch context builder is the union of the other 2. It carries the reports for the primer plus entities, relationships, and text units for the follow-up loop, with embeddings for HyDE. Then the config sets our 3 knobs, primer folds, drift K follow-ups, and end depth. These numbers literally shape the action tree. Step 6, run it. We construct DriftSearch with the model, the context builder we just assembled, and the tokenizer, exactly the constructor we introduced. Then one await search.search kicks off the whole pipeline. The primer drafts with HyDE. The follow-up loop drills for end-depth rounds building the action tree, and consolidation fuses it. Out comes resp.response, macro and micro together. Step back and look at what the lab delivered. From one set of index artifacts, we stood up all 3 engines and ran each. Global's MapReduce, local's entity spotlight, and the full drift pipeline end-to-end. That's the complete query side of Microsoft GraphRAG, top to bottom. Construction was Module 2, the search side is now in your hands. Same index, 3 working lenses. There's a shadow over everything we built, worth naming honestly. That community report index is expensive to create and expensive to keep current. Every mode depends on those pre-written summaries, and the moment your documents change, they can go stale, and rebuilding costs real tokens. The richer the index, the heavier this burden. That's exactly what the next methods attack. Let's tie it together. One GraphRAG index, built once, TextUnits and entity graph Leiden communities reports. 3 lenses, local anchors on entities and reads the neighborhood. Global MapReduces over summaries for sense-making. Drift primes globally, loops into local detail down a confidence-gated action tree and consolidates. Pick the lens by the question's shape, mind the cost ladder. Which sets up Module 4. If GraphRAG's superpower is community summaries, its Achilles heel is what they cost to build and keep fresh. The next method, LightRAG, goes straight at that pain. A lighter, dual-level retrieval scheme that updates incrementally instead of rebuilding the world every time data shifts. We've felt the cost problem, next time we fix it. See you in Module 4.
If you like this video, please subscribe and share. Thank you.